Hi everybody, in this lesson we're going to be working with box plots. So hopefully you remember what box plots are, but if you don't, we're going to talk about it in this lesson. So shown below are the scores of 15 students received on a math quiz. Find the median for these data. Let's do this without using a calculator. So the median is the middle number. What's the number that splits the data in half? So hopefully you remember the way that you do this is you kind of cross your way in because they're in order. Low, high. So I'm going through and marking one off from each side of the data set. So the median, the middle number, the median that splits the data in half is 27. Now what we're going to do is we're going to develop something called a quartile, which has a stem of quart, which means quarter, right? 25%. What's the first 25%? Well, I just cut it in 50%, so let's do the game. Let's play this game again. Let's go through and chop off these numbers as we go in from each side. So from this lower half here, ready? Chop, chop, chop. Let's find the median of that. So Q1, the first quartile, is 22. The first 25% of the data happens at 22. And we can get an upper quartile, a third quartile, by doing the same thing. So chop, 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 chop. And I end up getting a Q3 of 29. So notice this is the upper 75%. Well, you might be asking, where's the second quartile? We went from first quartile to third quartile. Well, that's what the median is. The median is Q2, the second quartile, the second quarter. If I have two quarters, that's 50% of a dollar. That's 50%. So we will never do this by hand. We will use a calculator. In this case, we're going to use Desmos. We're going to use a calculator. Do not find these by hand ever. So in addition to these three values, we can talk about the max and the min to make a 5-number summary. So I need the min, the maximum, Q1, median, and Q3 to make a box plot. So what's my minimum? How low do I go? 21, Q1, median, Q3, and maximum. So when we make a box plot, we draw 5 lines. Minimum, Q1, median, Q3, and maximum. And we make a box with the middle 3 and then add on some whiskers to the other 2 lines. So again, it's minimum, Q1, median, Q3, maximum. The minimum and the maximum are kind of the whiskers at the end. Q1 and Q3 make up the rectangle, and the median's in the middle of the rectangle. Well, not in the middle, wherever it falls, but the median's inside that rectangle. So find the range of all quiz scores. So remember from last video, range is max minus min, high minus low. 32 minus 21, the range is 11. Done. So box plots have the 5-number summary. They give us 5 numbers that describe the data. And box plots cuts it into quarters, cuts into 25%. So there's 25% of the data here, 25% of the data there, 25% of the data there, and 25% of the data there. That's what a box plot does. It cuts me into quarters. So consider the box plot of the ages of people from a random sample who watched The Wheel of Fortune. What a great show, The Wheel of Fortune. State the 5-number summary for this data. So I need the 5 numbers. Min, Q1, median, Q3, max. Well, let's get that right from the box plot. I'm going to kind of guesstimate here. So my scale, 0, 10, 20, 30, 40. So 2, 4, 6, 8, 10. It's going by 2s. The minimum age is 10, 8, 6. Q1 comes from this first part of the box. Where does that start? That starts at, I don't know, let's just say 40. Median's in the middle. Median's the middle line, 60. Q3 is the upper part of the box, 70. And then the last part is the maximum, I don't know, let's say 75 about. We're just kind of guessing here. What I want you to understand is you can work backwards with a box plot. Here's some values. Can you get me the 5-number summary? State the range of the age of the viewers. Max minus min. That's how I get range. Max minus min. 25, 75 minus 6 is, what does that come out to be? That comes out to be 69 is the range. The ages are 69 years apart from each other, the highest and the lowest. What percent of the data does the box part of the box plot capture? So what percent of the data is in this purplish, it's a nice kind of purple, in this purple shaded box here? Well, remember, I cut it into quarters. Each part's 25% between the next value. So the box captures 50%. What about low to Q1? Low to Q1 is 25%. What about Q3 to high? That's 25%. And can you tell me the average from this box plot? Can you tell me the average? No. A box plot tells you these 5 numbers. That's it. It doesn't tell us the average. No, you can't find the mean. Do you know how many people I surveyed? You have no idea. The only thing a box plot tells us is these 5 numbers. A dot plot, you can add up how many dots, or a histogram, you could add up all the frequencies. You can add up how many, what's the height of each bar. With a box plot, we actually can't do that. All we can tell is where these 5 numbers fall. So let's do one on the calculator, and then we'll call it a lesson. So Mrs. Perry gives a math test and records the grades of her 17 students below. Create a box plot for this data. So the way that we're going to do this is we're going to go to Desmos. We're going to type this into a list. So I need to put this into a list with square brackets. So here we go. Let's go to Desmos and type this on in. So I'm going to say, you can use whatever letter you want. I'm going to say lowercase a just for ease. Or I'm going to say x, make my life easy because x is right there. X equals a square bracket. X is going to be a list of numbers for me here. Here we go. I took a picture so I don't have to flip back and forth. 67. Be nice if I actually type the numbers. 67. 72. 74. 74. 78. Actually, let's not use X. I don't think that's a good idea. Let's use A again. Let's use A. X was a bad idea. 78, comma 80, comma 80, comma 82, comma 95. Ooh, this data is not in order. It looks like it's in order, but it's not. 2 95s there. 86, 87, comma 90. I forgot a comma there. I know it's tedious, but it's okay. You'll be okay. This is the hardest thing you have to do all day. That's you got a good life there. All right. So I typed in all the data. It says 17 things, which makes sense because it said Miss Perry had 17 students. So let's make a box plot. So guess what you could type in? Box plot. Or you can go to functions. Statistics and distributions is where we're going to be working. I want to visualize a box plot of A. Well, I don't see anything because I got to hit the zoom plus button there. And there it is. There's my box plot. There's my data represented for me with my low all the way up to my high, Q1, median, Q3. Well, how do I get those values? Well, how do I get my 5-number summary? I'm going to go to stats. I want my minimum. I want the minimum of A. I want my first quartile. How do I get my first quartile? So functions, quartile. Look, it says quartile here. Don't go quantile. I want quartile. I want the quartile of A, but which quartile do I want? I'm going to say comma 1. I want the first quartile. Now I want the median. I want the third quartile. So I'm going to go back to quartile. I'm using list A, comma 3. I want the third quartile. And then finally, I want the, I'm just going to type this in, max, parentheses, A. So there's my 5-number summary. It's in those statistics. That's how it made this box plot here. It used those 5 numbers to make the box plot. So let's copy those over. Let's copy those numbers over. I'm going to take a picture so I don't have to flip back and forth. So my minimum is 67. My Q1 is 76. My median is 86. My Q3 is 93.5. And my max is 98. So I draw lines in. 67 is about there. 76 is about there. Just guesstimating. 86. Definitely don't know where 93.5 is, and 98. We box the middle 3 and then draw some whiskers. So let's look at this new term called the interquartile range. It's a new vocab word, but it should make sense what I'm looking for here. I want the range of the quartiles. So the interquartile range, well, how do I find range? Range is max minus min. So IQR, the interquartile range, is the difference of Q3 and Q1. What is the range of my quartiles? What is the range of my inner quartiles there? I don't want the range. I want the range of my quartiles here. So 93.5 minus 76. 93.5 minus 76. Let's see what that is. 93.5 minus 76 comes out to be 17.5. It equals 17.5. How do we see the interquartile range? Well, the interquartile range is the length of this box here. The length of the rectangle, it's the length of the box. And what does it represent? It's the middle 50%. It's the spread of the middle 50%. It's a measure of spread. Instead of talking about standard deviation, I could talk about the IQR, the interquartile range. The middle 50% of my data is spread out by 17.5 points on the test. So the IQR, it's a new vocab word, is the range of the quartiles, Q3 minus Q1. Whereas plain old range is max minus min. I'm looking at the range Q3 minus Q1. So again, I can use Desmos to make a box plot. I literally type in box plot and then hit the zoom button to get me back to get me to the distribution. And then I can type in min, Q1, median, Q3, max. Reference back to this video if you need help doing problems on the problem set. And I'll see you guys next week.